Okay, let's see how this goes. Ready? Okay, so we have our in-class assignment, which I'm going to be showing you guys, and we're going to be walking through this step by step. So first we have create a year variable that counts up each year. This process can be done by a simple if statement. Okay, so I have everything here. So we need to clear this all out. Okay, so let's begin. First off, we have a year variable here that's in 1/1/1976. Okay, perfect. It's in date formula. And now what we're going to do is we're going to try to separate the year, the month, and just the year and the month. But we're going to first start out with the year. So our first part is just getting the year on its own. And Excel has an inbuilt command that you can easily pull out just the year by magically writing year equals and then grabbing the column and then pushing down. Boom, done. And same thing for month, right? Like, so if you have a month column and if you write month here and you grab that first cell, it's going to automatically grab out that month indicated variable. You can kind of see that if we go into, let's say, format cells, you'll see that it's in the date format. And so, yes, it can just automatically pull that out once it knows that it's in a time stamp kind of format. But what we want to do is make that year count variable, which is going to be a little bit kind of more tricky. And I mean, essentially what we could do is we could write, okay, 1 for the first year, 2 for the second, 3 for the fourth, and so forth. But that would be exhausting. And there's like 49, so we don't want to do that 49 times. So we want to think of a way to do a loop where we can be able to make a count variable and make the computer work for us, basically, right? So first off, what are the simplest loops? And one of the easiest ways to do loops is just writing an if statement. And so if we can think of a logical test that adds itself to itself, but does it when something is equal, then we have a simple loop statement that we can just like easily tell Excel to do for us. So to think about it, okay, well, we could say, hey, is this variable greater than the previous variable? And if so, then take the previous variable of the column that we're in and add 1. Then, if it's not that, just keep it the same. And that should provide us a counting variable that counts up for every changing year. Perfect. Okay. So that was our first test. Now we have to do this regression, 1 with year, and I feel like such a dork that I didn't read this when I was in class, but okay, so we have this one. We actually do. I did ask you to run it both for year and both for the count variable. Okay, so we're going to do that. Insert, or data analysis. Here we're going to go for regression. We're going to tell it, hey, grab the real value. And let's start out with our year. Grab this year value. And we'll put it over, let's say, H1. We don't need the residuals. We don't need the plots for this run to keep our stuff a little bit clear. Okay, we have our regression. Now what we're going to do is we're going to go, if you can't see it over here, it's this data analyst tool. We're going to hit this guy. We're going to now add in our year count, which is here. And we're going to put it in a new box because we need to put it in a new box. We don't want it to cover up what we just did. Let's say Q1, and then let's run this regression. Okay, here we have it. Now, the big thing I wanted to point out to you guys was, hey, this is year count. It's 0.009711, which is the exact same as we got with just the regular variable that's 1976. So without it being a count variable, we get the same coefficient. That, of course, it makes sense because it's going to be running the same thing. The difference here, the big difference that I forgot to mention in class, is going to be the intercept. because the magnitude is bigger in using the actual raw number, you're going to have this coefficient that's going to compensate for that magnitude, and it's going to hit that y-intercept at a much larger number, so negative 16. But if we look at that count variable, we hit it around 3, which is perfect, because if we look at the data over here, bring this, the data starts out around $3.41. When we look at adjusted values for gasoline, if we adjust for inflation to what the cost of gasoline was in the 1976 era, it was around $3.40. Nominally, without inflation, it was about 60 cents. But counting for inflation, purchasing power is roughly about $3.41. Okay, there we have it. There's that first one. So that's kind of the big thing. The coefficient for the main variable doesn't change, but the intercept does. Okay, one other thing is this 2%. It is only basically explaining 2% of the variation within the data set when we're just trying to control for yearly variation. It does not explain overall variation of the data that well at all. So other things are happening. Let's go back to the questions. And now we have, okay, create a quarter 1 to 3 dummy variable. We're only creating 3, even though there's 4 in a year, because of the fact that, we have to drop 1 when we run a regression. So we could make a 4th, but we could just make 3. And inherently we know that the 4th is what we are comparing all the 3 to. Okay, so we go over here. We have quarter 1. Let's move this over and insert a couple of cells. So can I just scroll this over? Yes, sweet. Okay. And this one, we're going to also need to write a if statement. And what we're really interested in, since we already created a month variable, is if this month variable is less than 4. Because then if it's less than 4, it's going to be in that first quarter. I could have also written it as, is it equal to or less than 3? But instead I've written it as less than 4. Okay, for the next one, it's going to be a little bit more complicated, because we're going to have to say if, and we're going to be asking it to do two conditions. We're going to ask it, hey, is it less than, or is it greater than 3, but less than 7? So to do that, what we need to do is add an and. We're going to put this in here. We're going to say, are you greater than 3? Or are you less than 7? And then close that parentheses, give it a 1 or a 0, 1 and a 0, and boom, here we have it. And now we have for quarter 2. And we can do that lastly for the same one. You're still going to need an and statement here. You're going to tell it, hey, what month is it? Is it greater than 6? And is it less than 10? No, I just need to write 10. Oh, that's why 10. 1, 0. Close parenthesis. Oh, this needs to be close parentheses first. Then it needs to be 1. Then it needs to be 0. Then it's... Oh, this needs to be 0. Close. Okay. And here we have it. Okay. There it is. We have our first quarter, our second quarter, and our third quarter. Sweet. Okay. So now back to our questions, and it's going to ask us to do, now let's compare months versus quarters for this description. So we're going to go, hey, we're back here. We're going to do a data analysis. We're going to say, hey, let's take this regression. Okay. It's freezing on me. Oh, I see why. I need to hit this button. Okay. We have that. We have our Y. Now we're going to say, we'll take the year count and we'll put it down and we'll say, okay, let's compare months, and we'll write over this guy. And then we're going to do quarters, and we'll take this year count and we'll go all the way over here. Yes, right. What do we have? Oh, shoot, I didn't mean to write over that. Okay, shoot, I messed up. Okay, we're gonna have to do this one more time. We're gonna have to go year, month. Here we go. Dun dun. Okay. And then we'll say it's okay to write over it, and then we'll do it again. We'll grab this new one, and what we want. Oh, grab this guy, and we'll hold it down. Okay, and then what we're gonna do. So we're going to move it. We need to move this guy to this new area. Okay, plot it. Okay. Another thing actually we should do here is let's plot out our residuals. Yeah, we'll just plot out a residual. Okay. Let's actually even do the line plot fit. I want to see what that looks like. Yeah, go over it. Oh, no. These line plot like stuff is not that cool. This is cool actually. So that basically answers one of the questions, but it's not that's not a good, I don't think that's a good enough graph. Okay, anyway. Okay, so let's look at these two regressions. Here we have intercept, month, and year count. When we look at our R squared, it hasn't gone up much since the last time when we had just the year in there. And basically what we see is a non-significant month variable. So it doesn't explain much. But when we move over here, we see, okay, it went up like 1%. Not like super great, but it went up 1%. And what we have year count remains fairly the same. We have the intercept now a little lower than 3. And these quarters, not significant for the first one. The second one is about 10%, and the third one's about 10%, and they're positive, which makes sense. If we think about what's happening in the second and third quarter, it is the spring and summer. So it is April, May, June, July, August, September. And that is the time in the United States that people are traveling, they're vacationing, more people are out and about, it's warmer weather, they're making their travel, summer plans. So it makes sense that you see this positive increase because demand is going up during this period, and it's slightly significant. Okay, so plot out the real, nominal, and predicted values. Does the variation predict well? So what we did back here is when we asked it to plot out the residuals, it actually predicted the real values for us. So we can take this and insert the copy cells over here, shift. I don't want to shift them down. I want to shift them over. Insert. Okay. I'll take this guy, copy. Okay. And here we have our predicted values. Okay. Perfect. We can also now grab these nominal and predicted values, highlight those, and then lastly, highlight our time. Oh, shoot. Redo it. And highlight our month, our date series. Sometimes when you highlight the date, as the last part to grab, Excel reads the data better. Oh, shoot. That didn't get the predicted values. Okay. So we need one more time. Here we go. Okay. Now, there it is. There we go. Here we have it. Okay. So that I'm kind of blown it out a little bit. Yeah, there we go. So that's actually even worse for you guys to see, isn't it? We're going to need to move this guy. Oh, not that. Let me come over here. I need to make this a little bit easier for you guys to see. How do I do it? There we go. Okay. Basically, what we have is this is the real adjusted values. So the actual adjusted values for inflation. Now, I think I told you guys, well, I did tell you guys this in class, is that if you'll notice that these really overlap pretty well when we get to where we are today. And that's what they are supposed to do, because what you see in real adjusted values typically, depending on wherever the reference point of the adjusted dollar would be, the two nominal, this is the nominal, this is the price of gas in actual dollars at the time without inflation adjusted. You know, it was, your purchasing power for $1 was a little bit more back in the 70s, but that doesn't mean that it, because of inflation, if you don't adjust for inflation, you're not really getting the true actual value of how things are changing over time, because inflation changes the amount of the money supply in general. Okay, so when they overlap, that kind of tells you, hey, this is where the reference point is. We're looking at this in 2023, 2024 dollars, and we're looking at gasoline prices of what 2024 dollars would have looked like in 1970s in the past. This gray line is our predicted values. That's what the line is predicting. It's predicting, you can see, a little bit of linear upward, right? And these very much like quarter trends, right? You can just see like bloop, 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 bloop throughout each quarter. Doesn't do great for predicting totally what's happening within the data. Other things clearly are happening in gasoline prices over time. So let's continue on. Yeah, that's what that says. The next thing says, use the equation that predicted the best linear fit from the row 5 and predict each month from 2024 to December 2025. Okay. Now I think I already have it in here, right? Basically, you write this up. So you wrote, I write year, and I know that in our original data set, if we scroll down all the way to the bottom, it stops this month in the data set that I gave you guys. Stops in October of 2024. So let's take November, December, 1, 2, 3, following the next year, and create a data set with our our quarters, right? So these would be 2 would be 0 because it is the fourth quarter. So these all 3 of these would be 0. We have these 3, we have another 3, we have another 3, and then we have these zeros again. We were in the 49th year, and then the last one would be 50, and we had our monthly as well as this yearly variable. And so essentially what we're going to do now is we have a predicted regression right here. You see, that was like what they produced versus what we produced. I think what we produce is a little bit cleaner. But okay, so we can take our summary value, we can highlight it. Let's put it over here. Now we have this equation that gives us a way for us to predict into the future what it's going to look like next month. And so we can take, what we could do is we could, let's say, I want to paste the values to tell you the truth. Okay, well, you know what? Fine. Here is our equation. We first take the intercept. That is itself. Nothing times, we don't times it by anything. Then we have our next variable, which is our year count. And we times that by this 49 because that's the equation we're using. And then we also have this quarter, which is you want to, do those dollar signs because we don't want that to change over time. And then we just highlight it that it's gonna be first quarter. Then we do that for our quarter 2. And we highlight, or we lock it in, and we do this plus this guy. We add in our dollars again, and we times it by this guy, and boom, we got $3.44. We bring it down. We have roughly a little fluctuation. It goes up to $3.60 and then drops back down to $3.40. Now, I have you guys do this, but the government actually in this one has predicted these values into the future for us and have already a fluctuation kind of embedded linear regression that they're using to predict their own values. So we're going to compare what our very simple modest equation, how accurate it is to what they're doing. And that's on this governmental page right here. So we can go to our this sheet that we did this prediction. We can copy it over here. We can go to our government predictions. Oh, and I already have it here, but we'll recopy it. And here we have it. So basically, the government right now is projecting that the gasoline prices will go down. And they will go down all the way to below $3 on average across the United States by 2025. Our regression right now, because of the that linear trend that we're predicting, says that it's going to roughly hover around the same thing. So our prediction is pretty off, right? And it's likely because we're not controlling for a lot of stuff. There's a lot of things that could be going on. The data within the government could have better explanations of like what's going on with OPEC, as well as understanding demand and projections and what they're planning on drilling out of public lands or whatever it may be, or how much they're thinking about releasing in, and the amount of supply that they are projecting out into the future that gives them a better accurate prediction. The other thing that I want to point out is that if we look down here to the bottom of our data, right? Can I zoom in? Yeah. Okay. It was higher in the summer, which makes sense, right? More people are traveling, the demand increases, prices increase. But as we get down into, we see a faster drop occurring here than we do in our predicted value. And I think even in our picture, right? You can really see that in, where is that? That's not it. There's got to be. Where is our, there it is. Okay. Sorry. You can really see where our line is. It's quite a bit above some of this time, right? Like, so here was a pretty big lull. Then we had a spike. What is this spike? When did this spike occur? This is like in 2008. What happened in 2008? A major recession. And we see the price drop and we see these fluctuations. There's a lot more things going on. And we just came out of a real high, like, top. So maybe there are other things that we're not necessarily controlling in our data, that's making our data quite a bit above of what's happening in reality. Okay. Let's move on. So, actually, I'm going to stop it here, and then I'm going to, this is 20 minutes long. I'm going to stop it here, and then we can go on to this events that disrupted oil prices. I can post that later. Okay. We can talk about that in class.